variable, we're going to suggest you there's a causal relationship. We're going to ask you to propose a possible confounding variable. This confounding variable doesn't have any kind of specific answer. It can be anything. But the most important part is you have to convince me why this first variable is a proper confounding variable. It has to affect x. It has to affect y as well. So you have to introduce and argue these two channels exist in order for that to be a proper confounding variable.
Are you going to ask us to ever give an example of like intervening?
Yes, but it's less important. So intervening variable will be something like this. X is going to lead to y, but through z. Okay, so an intervening variable in this case will probably be something like, because you're in private school allows you to have maybe like a smaller classroom. This variable, smaller classroom, which boosts up your score. So in this sense, smaller classroom does not confound this relationship. It helps to explain this relationship actually. So no, but it would be nice to distinguish, for you to how to distinguish between this relationship x leads to z leads to y as your intervening variable and confounding variable, which is z is going to cause both x or y. Any question? Right, so the important part here is be sure you have to provide answers for both of these channels, how it affects x, how it affects y, so that it is convenient as a proper confounding variable. An observational study, which means we only observe the relationship between two different variables. We can never fully eliminate the possible influences of confounding variable. It's just impossible because there's so many possibilities of confounding variable we cannot control for them. We can try to control for them using kind of techniques, but we can never fully eliminate its influences. So observational studies might suffer from what we call selection effect. Selection effect basically means that you are comparing different things. Because, like in the case of this, you're saying that you're comparing between public school, and private school. But it is very, very possible that students in public school are not comparable to students in private school. Because students in private school they have higher income, and they select themselves into private school. And students in public school may have like lower income, so they select themselves into public school. So the two groups of students are comparable. You're comparing apples and oranges. You cannot draw any kind of proper inferences from that. So like if you want to know like if eating a chocolate is going to make you fat, you put a bunch of chocolate here and ask people to just like take it. Those who like chocolate is going to select themselves to eat chocolate. Those who dislike chocolate is not going to eat chocolate at all. So we cannot compare these two differences and say that chocolate makes you fat. Okay? So that's what we call a selection effect. And selection effect by nature is going to invite the influences of confounding variable. Whenever there is a selection effect, your group is not comparable because it's not comparable due to the possible influences of all kinds of different confounding variables. So what do we do with it? When we're doing observational study, when we're doing quantitative study using statistics to understand things, we can kind of include control variables, like include a bunch of variables into our regressions, or if you still remember, in the case of crosstab, we can include like a variable of income and make it down two crosstabs and to compare the value and try to see if by controlling so can provide us with a better claim, or at least causal claim. Now, yesterday you learned about qualitative research. So the only difference is that qualitative research you basically don't use statistics. They're more kind of like small cases. They only compare between like 1 or 3 cases. So they are using more in-depth methods to understand like focus group interviews, these kind of, they don't quantify their variables. They use more like literacy to describe what's going on between these two variables. So qualitative research has 2 kind of techniques they can use to kind of control for confounding variable. Is what we call the most similar system design and the most different system design. So this is better understood using this graph. You can see at the left side of the screen over here, MSSD, that's the most similar system design. So basically what we're doing here is, the feature you can think of this as confounding variable. we identify some possible confounding variables, and we select cases that have the exact same values on all of those confounding variables. As you can see, we're comparing countries. Country 1 has ABC on the 3 confounding variables. Country 2 is same, country I is same as well. And then, suggest we have like a key independent variable over here. If the confounding variables are controlled to be similar, then whatever differences we observe in the independent variable, if that leads to differences in your dependent variable as well, such that you can see these two countries have the independent variable of x, and then leads to outcome of y. But this country does not have an independent variable of x, and that does not lead to y. Then we can attribute the difference in the outcome solely due to the difference in the independent variable. Does that make any sense? So the most similar design is that we select cases that have the exact same value on the possible confounding variable that we think might be influencing the relationship. So whatever differences happens in the outcome is going to be because of your key explanatory factor, your key independent variable. And the different system design is a little bit similar in the case, but what they do is that they specifically select cases that have completely different value on all of the confounding variable, but have the same value on the key independent variable. So if all of these cases have the same value on your independent variable and leads to the same outcome as well, then it doesn't matter whatever difference is going on there in those confounding variables. You can still attribute the outcome solely due to the influences of your independent variable. Does that make any sense? Is that clear? Okay, so the only difference is that are you selecting cases that have the exact same value on all confounding variables, or are you selecting cases that have completely different, it cannot have any kind of same value on all of those confounding variables, and then you use your key independent variable to try to draw some inferences. So this is how qualitative research, because they have like small cases, they basically just like compare maybe 3 to 5 countries. So they can find a set of confounding variable, try to control for it, and then draw some inferences based on your independent variable. But it's not perfect because we don't know whatever confounding variable is out there. We can only select some that might be possible, but it is impossible at the same time for us to know if there are any other confounding variable that might influence our result. So this is how qualitative research control for confounding variable, but it's important at the same time to know that it is insufficient at the same time because we don't know if we actually properly control for all possible combination of. So the best way to eliminate confounding variable is to do a randomized experiment. Is to remember, using randomization, we can assign treatment to a group. We can assign the other group is our control group. By nature of this randomization, it's going to eliminate every single possible confounding variable out there. Whether we know it or whether we don't know it, doesn't matter because it's all 50-50 chance. Okay? So in this case, if you run a randomized experiment, the groups are perfectly comparable because due to the nature, the virtue of randomization. So randomization can eliminate the selection effect we just introduced. It can eliminate all kind of possible influences of confounding variable as well. The only differences you observe can be solely attributed to the existence of the treatment. So randomized experiment is very, very important. It's very good for us to draw causal inferences. At the same time, it is very highly unlikely to achieve. In the case of the country, you cannot randomize country to have some kind of treatment or not. It's just impossible. And even in the case of the school, you cannot randomize students to get into private school or public school as well. So experiment is very, very desired, but sometimes it's very difficult to achieve. So you have to recognize that there is certain difficulty when we're trying to conduct any kind of randomized experiment. But nonetheless, it is the best way for us to eliminate all confounding variables. It is the best way for us to establish causality. Any question? Right. So about understanding causality. Any question on causality as well right now? Right, so we can enter to measurement and distribution. This, we're just going to skip very fast because it's very simple or like very basic knowledge. Nominal variable, ordinal variable, interval variable. Nominal is just basically different categories. Doesn't have hierarchy, gender, race, options on a menu, whatever. Ordinal variable are just categorical variables, but they have a certain hierarchy between them. Like in survey question, strongly disagree, neutral to strongly agree, that's a ordinal variable. Or if you ask your opinion toward Trump's approval rate, has it changed, decreased a lot, or increased a lot, or didn't change? That's a ordinal variables as well. And during the midterm, some of you got this wrong in like age and income groups. When you're thinking about age and income, you might be thinking about them as interval variable because we say that any numeric measures like income, age, height, weight, or whatever percentage, that's deemed as an interval variable. But when they are categorized into groups like age from 10 years old to 20 years old, 21 years old to 30 years old, 31 to 40 years old, that becomes a categorical ordinal variable. Okay? So that's kind of important things you don't want to get wrong. Any question on this? All right, measurement distribution. Three of the indicators about your distribution. Mean is basically just the average value distribution. Median is the 50% right in the middle. So if you find a median value, you can know that 50% of the value is going to be greater than that value. 50% of the value is going to be less than that in that very distribution. And mode is basically the value that appears most often. In the case of list distribution, like the highest one in your histogram is going to be your mode here as well. So these are three different indicators you might want to know. Any question on these? And if you remember, for normal distributions, the mean is going to be equal to the median is going to be equal to the mode. And for this positive skew, right skew, the mean is going to be greater than the median. For the negative skew or left skew, the mean is going to be less than the median. A lot of you kind of confused that during midterm as well. For this, mean is going to be greater than the median because we have outliers over here that contains very high value. That's going to draw the mean to be a little bit skewed over here. And for this case, the outlier is in the low value, so it doesn't matter if there are a bunch of values that's very high. If there's a very, very low value appearing over here, then the mean is going to be drawn here as well. Right, so the most important distribution we're interested in is the normal distribution. And if you remember the first statistical property, we said that is very, very important. We have to memorize that 68% of the data point is going to fall between one standard deviation. 95% of data points are going to fall between two standard deviations from the mean, and 99.7% of data points are going to fall between three standard deviations. And this is the most important thing. If these properties, 68, 95, and 99.7 only occurs when we state the data is normally distribution or when we state the data is normally distributed, okay? So if I draw like a bimodal distribution, like McDonald, and we give you an X, we give you a standard deviation, can you apply the 68, 95%, 99.7% to this distribution? No, right? If we draw like a perfect bell shape, symmetric here, and again we provide you with our mean and our standard deviations. But in the question, we didn't mention anything about normal distribution. Can you still apply that to here? Even if it looks like perfectly like a bell shape, perfectly symmetric? Yeah? No, you still can't, okay? So the trick is look in the description of the question. If we never mention anything about normal distribution or normally distributed, then it doesn't matter how close distribution looks like the bell-shaped thing. It doesn't matter. If we never mention it is normally distributed or never mention that this is normal distributions, then you still cannot apply those three properties to describe the dispersion of the data. Okay, that's important. So whenever you're reading questions, pay attention to whether or not we mention about normal distribution or normally distributed. Release. That's for the measurement So now we enter into statistical inference and hypothesis testing. So the basic idea of statistical inference is that we have a population parameter, that describes the populations. We have statistics that describe the sample. Population parameter, what we want to know, can only be estimated, it cannot be observed. Sample statistics are things that we know, we can already observe. So statistical inference basically infer what's going on in the population based on what we observe in the sample. Okay? That's very simple ideas to know, and during the final you have to know how to identify the populations. If we provide you with some kind of poll that's asking like the adult in Merced County, then you have to know that whether that sample, how that sample attaches to the populations that you're interested in. Any other question? I guess that, oh yeah.
What was the type of question that you'd be asking about again?
Maybe just some kind of like a result of poll, like the analysts under 1,000 adults nationwide, and basically just ask you like if that's your sample, then what might be the population you're interested in. In that case, would be the American adults. It's very intuitive. So since the population parameter can only be estimated, so the technique we use the most is what we call the 95% confidence interval. For any sample statistic, we can construct a 95% confidence interval. That's going to be equal to this equation over here. This equation is important. Sample statistics plus or minus the margin of error. Okay. So for any 95% confidence interval, the sample statistic we're asking is going to be the base. And you minus that with the margin of error, that's going to be the lower bound of your interval. You plus that with the margin of error, that's going to be the higher bound of your interval. And between those two values, that's going to be your 95% confidence interval. Yeah.
We don't have to calculate the margin of error, right?
No. You don't have to do anything beyond plus or minus. That's all. So formally speaking, if our sample statistic is a mean, then you use this equation. And if our sample statistic is proportions, you use this equation. Now, you don't need to perform any kind of multiplication or division or square root. But do you need to know about these equations? I would say it's not necessary for you to know about this equation, but it might be good if you can identify which of the equation we're going to use when we're calculating 95% confidence interval.
So like on the quiz we were given like voters or whatever it was, like that population, we won't be asked something like that?
Something like what?
Like to calculate anything?
No, no. So I have like a sample question that I'm going to show you. So the question on the quiz is going to be more that we're going to give you the margin of error and some sample statistics, and the only thing you do is you have to identify which sample statistic we're asking, and then find a margin of error, do addition and subtraction. That's all. And like I said, for these equations, you don't necessarily need to know them. It won't hurt you if you don't know them, but it might be good if you can recognize the things in these equations. So what's important is this is definitely what you're going to remember: sample statistics plus or minus margin of error is the 95% confidence interval. Okay. So here is an example question. Suppose we conduct a poll, as you said, sent to this opinion toward Lake Walk as well. Suppose representative with the size of 44, the margin of error is 5, right? 95% confidence interval, level of confidence. So, if I want to calculate the 95% confidence interval for people who think the Lake Walk is bad, how do I do it? What's the first number we look for? 80, right? That's going to be our simple statistic we're asking. What's the second number we're going to look for? Which is right. And what are we going to do with this? It's not necessary to do that, but it's the same. You can show that in percentage or decimal. It's fine. we're going to write add and subtract. That's going to be equal to. Right. That's how you find a 95% confidence interval. That's about all the calculation you need. But if in the question we instead ask you to find the 95% confidence interval for the proportion of people who think it's good, then we're going to find how to do it.
13%.
13. And
Plus or minus 5.
right, it's the same. The margin of error doesn't change. The only thing that's going to change is the proportion of people, the sample statistic that we're asking. Okay? So, on a quiz, it's probably just going to be something like this. We're never going to ask to calculate the margin of error. We're going to provide you with that. But we're going to provide you with a bunch of sample statistics. Proportions might not just be good or bad, and sure, it might be like 5 different categories with 5 different percentage. You have to identify in the question which one. And then just do it. That's all we're going to do. Any question on this? Right. So we are also going to ask you how to interpret this. If you remember, the correct interpretation is we're 95% confidence that the true parameter is within this interval. It doesn't mean that the parameter has a 95% probability to be within this interval. So we take these cases. It means that we are 95% confident that the true proportion of users is likely equal. It's going to be between 75% and 85%. So you have to use like more precise language up here, and like in the quiz, some into this as we're 95% confidence that between 75% and 85% of the students is going to dislike. So that kind of suggests that you're estimating a range. But the true proportion